Okay, today what I'm going to do is just give a bit of a brief introduction to scientific foundations and maybe go a slight little bit beyond what's in the book just to give you a sense of kind of how research literature is curated perhaps and kind of how that fits in because I guess a lot of you won't be directly involved or using that, but I think it's useful to know because there's some nice overlaps that you can hopefully find as we go through with the research community and your own interests. So the idea is that this won't be long. I'm hoping it will be 45 minutes or less. Less is the aim. So hopefully you have managed to have a read of this book. So the section that you're interested in for this class is chapter 4, which is kind of all about what scientific foundations is and what research is. That will then kind of lead us in a little bit further into how we can design experiments to prove hypotheses and things. So I think I need to click over here. Yeah, okay, so research itself, so Mackenzie says it's kind of aimed at discovery and interpretation of facts, and I think that's true. In HCI, it's about kind of gathering facts, formulating theories, and testing evidence. And the difference between that and other research is that there's a lot more qualitative research in HCI. So there's a kind of empirical research body which is looking at kind of proving things based on statistics or evidence. HCI is a lot about why someone uses something. So the kind of experimentation that you find in research is, in the case of HCI, related to user studies. And that's about whether things can be verified or disproved. And as I say, qualitative or quantitative. So when I talk about quantitative, I'm talking about statistics, numbers, probabilities of something being true or not. And when I talk about qualitative, I'm talking about things like interviews, focus groups, open-ended survey questions, and how you can take that data and analyse it. So when you publish within HCI, what you're looking for is that you've got some novel contribution to the field. And so that contribution that you give could be quite small, and that's okay because each kind of paper should then push science that little bit further. But what's important is that science is peer reviewed. So whenever, let's say, I submit to a conference, it is a group of my peers, i.e. other HCI researchers with similar interests perhaps, and they will peer review that paper. So typically that's anonymous. You don't know who the paper is, and I don't know who the reviewers are. But they're expecting that I've shown good evidence, that I've documented my analysis in some way, such that someone else can come along and reproduce whatever study I've done to get the same or similar results. And that's useful because often what we do is we reproduce study methodologies within different populations. So I might do something with a group of people who are blind and then try and adjust that methodology and do it with people who have a visual impairment who aren't completely blind and see what the challenges are between them and so on. So typically I tend to publish in the ACM, in the Association of Computer Machinery. You can find a whole bunch of papers within the ACM. It's not just HCI, it's broad spectrum across all of the kind of computing science topics. IEEE or Springer are the other ones. ACM tends to do conferences. So what you'll find is that a lot of papers that you read for HCI are conferences. And the reason for that is because it changes so quickly. To get something into a journal, you might be 6 months, a year, 18 months. Well, there's probably some new technology that we can use by then. So to keep things up to date, we tend to do lots of conferences. So the two that I am most involved in is Assets, which is an accessibility conference, and CHI, which is Computer-Human Interaction, or HCI in another way. So CHI 2019 was in Glasgow, that was fun. CHI 2020, I was supposed to be in Hawaii a few weeks ago, and instead I'm at my dining table, but that's okay. Assets this year will also be virtual. So the good thing about all these virtual conferences, by the way, is that they're super cheap. So normally to go to a conference, you'd be $600, just registration fee plus your fees to get you there, your travel, your accommodation, food. But I signed up to an ACM conference the other day and it was $60. So that's like £48. So yeah, I'll be going to lots of conferences this year. Okay, so CHI itself is part of a larger group within the ACM, and SIG stands for Special Interest Group. So this is a special interest group in computer-human interaction. Now, this is kind of the biggest association of professionals in HCI. You have similar SIGs, or you have SIGs for other topics. So there might be a SIG for database people, there might be a SIG for info visualization, there's a SIG for accessibility. But the HCI one, the mission there is to enhance the members' ability to innovate and understand technologies for the greater public good. So that greater public good, I think, is really important. So what, certainly in the community that I publish in, we're always striving to show some kind of impact. So when I come up with a new technology or a new design method, or I evaluate something, I have to kind of justify in that paper why something's worth doing. The motivation for that research needs to be clear. And that's part of the reviewing process, is that the reviewers will consider, is this a worthwhile endeavour and will it actually help people? So in terms of peer review, we've got an interesting setup over there. Okay. So this is the review process for CHI. So what happens is I submit my paper. My paper is assigned to someone called an associate chair. They have responsibility for about 10 to 15 papers that are submitted. They then send the paper out to reviewers. Reviewers complete a form looking at whether the work is novel, whether the work has impact, whether the work is well written, well presented, whether the methodologies make sense, all that sort of stuff. And we'll go over that sort of thing when we do the paper reading session. So don't worry too much about the content of that review, just know that it's being reviewed for kind of good science. Those reviews then get returned to the authors. Now, CHI, because of the size of the conference, can afford to do this next step. So your associate chair writes a summary of the reviews and sends them back to the author. The author then has what's called a rebuttal period. So if you disagree with the reviews or you want to show that you can take those reviews and make changes to your paper, you can then submit that rebuttal. It's sent out to the reviewers and they rescore the paper. And from that, there is a cut-off as to whether a paper is accepted or rejected. So that's kind of the process of how these things would kind of happen. So this is the data for CHI up until last year. So you can see these yellow bars that I'm kind of tracing here, these are the submissions. So CHI was kind of rumbling along, and then just at the turn there, 2000, 2001, it's really hit this upward spike. So the acceptance rate of getting into CHI is typically about 1 in 4. So 1 in 4 papers that are actually submitted will be accepted. So to have a CHI paper is quite an achievement. So last year was a really big conference. There was 5,000 people attended, roughly, and that's 705 papers across about 4 days. So it's huge. It's a big deal. So you can submit to conferences in lots of different formats. So you can submit full papers, or sometimes called technical papers. You can submit things that might be called work in progress or late breaking work. Those are things that you've just discovered. They're smaller pieces of work. They're maybe part of a larger thing, but you want to get the information out to people. That would go in there. There might be a workshop, and that is about something that you know about or that you can maybe teach people about, and having a session where you can all work together to solve some problems. So typically you'll get, so let's say I did a workshop on accessibility in social media. I'd have people who research social media, people who research accessibility, perhaps people with disabilities, all in one room to solve that problem, and posters. So posters are an interesting concept. in that you provide a poster. You provide it like a 2-pager usually, 2 to 4 pages, about your topic, and then you're invited to present a poster at the conference. So you can have a look on this call for papers. This is just the link here. So it will let you see roughly what a conference is asking for. So in this case, there's a whole bunch of different categories. If we go for technical papers, because they are the kind of main concept, it's important that things are accessible within ASIT's community, but there will be some information here that says this is what you should provide, this is what the conference is interested in, just to try and kind of keep some scope. There'll be some writing guidelines. There will be information on how long your paper should be, and there'll be information on how you submit it, what that review process, etc. So you can go and have a read if you want to kind of find out a little bit more. But anyone who wants to go and find the papers, if you just go to dl.acm.com, you'll get to the digital library. That is free probably for another month or so, just because of COVID. Yeah, through to the June 30th. After that time, you can access it using the VPN into the QMB, so anytime you want to. So you can either just type in kind of like people. So if I just type in me, you'll find a list of people. Yep, so this is me, so I can kind of, you can see all of the stuff that I've done. And from that, you can kind of click through to different conferences, you can click through to co-authors of mine, you can click through a whole bunch of stuff. So as an aside, if you're interested, it will pass an afternoon, I guarantee, very quickly. Okay, so we were talking about posters. This is some kind of idea about posters. So basically they'll go on the wall, and the idea is that it's then something to kind of facilitate a conversation. So this as a poster, not my favourite. Imagine you're in a physical space with lots of posters. Like, I can't read what the main outcome of that research is without honing in probably to about this section here, the conclusion section. So that's not super straightforward. This one has got a very clear, right, like, situational visual impairments are a growing complex usability, accessibility problem for people using mobile devices. So we're raising awareness of this issue. That's the point of the paper. And this one uses something called a better posters type format. It's kind of based on that, and the idea is that rather than having a title, the title of my paper goes down the bottom here, but this is my take-home message. And so that's very clear. So a lot of work can go into creating these posters. People can spend a long time. Okay, once you've now got all these things published, I've got my poster or my papers published. How do I then decide what are better papers? So there's an H-index, which is n publications, each with n or more citations. So if your H-index is, let's say, 5, you have 5 publications that each have 5 or more citations. Now, you might have 20 publications, but it's that number that has, it's that number of papers that has that number of citations that's important. So it's a nice encouragement in a way, because it encourages people to kind of keep their work at the forefront and do things that are collected. It's easy to cheat and just cite your own papers lots of times, which is kind of a way around for some people. But the more papers you have with citations, the bigger your H-index will be. And therefore that kind of maps to your impact. So how much impact are you having on the scientific community? Well, the more people that cite it mean more people have read it, mean more people are acting upon it. So you can go to Google Scholar. Yep, if I now show you that site, you can see, okay, CHI has the biggest impact. That's at the top of the list. Don't worry about the numbers and how they come to be. This is just a list of top conferences. So generally, the higher you are in that list, the harder it is to get your paper accepted. So everyone in HCI is aiming for a Chi paper. Just zoom in a little bit and let you see. And then obviously there's some ACM conferences again, which are quite popular. So how people kind of publish and the success rate of publishing depends very much on how many people are publishing and kind of the interest in that venue. But Chi is consistently like the top for HCI. So you would generally assume that Chi papers hold more value than a random conference that I created, because mine is small and doesn't have a lot of kind of impact. It's just brand new. The acceptance rate might be 80%. Whereas with Chi, because it's hard to get in, you've got a level of trust in those papers already. Okay, moving us along. You will see Chi papers, or just HCI papers in general, that follow lots of different methods. So some of those methods are about observing what's happening. So I want to go and discover what's going on and try and understand what's going on in there. And once I know what is happening and why it's happening, I can start to then implement technology or adapt technology to help improve that situation. So an example of that is I recently wrote a paper about people who are blind who use emoji. And we weren't coming up with any solutions. The entire paper is how do people with visual impairments use emoji, and what are the problems that they have, and why do they use emoji in that way? So that's an observational one. An experimental one, typically quantitative, I guess, is that you are measuring and analysing performance. So that might be, I have designed a new system to recolor a screen for someone who has colour vision issues. I've made 3 versions and I'm going to test them all and see which one is the best. So that's me manipulating which system I'm using to see which one has improved performance. So this book, the Scott McKenzie book, is very much about kind of experimental methods and statistical analysis within those methods. There's a third one, which is a correlational method, and that's about finding relationships between variables. So does one thing cause another? And that's not very clear and often misinterpreted. You've all seen like silly charts of correlations that just can't possibly be true. And I think I've got a few coming up. But in many cases, what we have is some kind of mixed method. So we have a little bit of observation, a little bit of experiment, so that we can give a complete overview. And that's part of the art of science, is how do I sculpt my methodology so that I can answer the questions that I have. So if we look at consider the first of these, kind of experimental type thing, or when I'm observing something. I might observe things in many ways. I might ask you to type and measure how quickly you do it. I might have a survey and ask you, why are you studying at University of Dundee? You know, that's a nice open question. Why? And you can write a whole paragraph about how great it is and why you came here. And, you know, I can start to do some textual analysis on that. So the observation, when I say observation, I don't just mean watching someone. I mean basically gathering information about something. And so these measurements that I take kind of fall into different categories. So some of them will be quite sophisticated and some of them will be quite crude data. So they are ratio, interval, ordinal, and nominal. So if you do them up the way it says NOIR, so that's pretty much how I remember them. And we'll start with N. So nominal is mutually exclusive categories. So that's things like counting how many blue cars go past, counting how many smiley face emojis were sent within the last 3 months. And from that, you can calculate totals and percentages. So by mutually exclusive, I mean things like postcodes. So you can't live in a DD8 postcode and a KY2 postcode. You have one residence, right? In HCI, sometimes these boundaries are slightly blurred. So often what you'll find is that you'll say you're left-handed or right-handed, and no one is really left-handed or right-handed, you just have a propensity towards one. You might be asked for your gender identification, so do you identify as male or female, or none of the above. So there's some nice work in HCI right now about how do you represent how people want to be represented within that kind of thing, because a lot of historical HCI in terms of kind of gender and gender psychology is all about differences, gender differences, and that is kind of becoming less of a focus. So it's interesting to see how people take that early work and turn it into something else. So that's nominal. So that's N, N-O, ordinal. So this is about ranking things. So the important thing is that things are in an order, but there's no set distance between them. So if you take the picture on the left, like Usain Bolt is clearly first by some margin, but position 2, 3, 4, 5, 6, they're all quite closely bunched together. Chili scales, you might have one chili that's crazy hot compared to the rest, and so you've got that gap. So you can compare whether people think that things are less than or greater than something, the amount of people who made it their first preference, but you can't calculate the mean because it's not a numbering sequence, it's just a ranking. If you want a numbering sequence, we're moving on to intervals, so that's about equal distances between the values, but it's important to note that there is no absolute zero. So if you take the example of a survey, so I have equal distance between these responses, right? But I don't have a zero. That is termed as being neutral. So I can calculate mean values, but if you think of temperature, like I can't say that 20 degrees is twice as warm as 10 degrees because there's no absolute zero temperature. Celsius temperature is a construct. It's not the true basis of temperature. So equal distances between them, but no absolute zero. Ratio is the most complicated, and this has got everything. So for ratio, you have equal distance between them, and I have an absolute zero. So this can be things like time. So it can take me 0 time, which probably means it didn't happen. It can take me 1 second, 2 seconds, and 2 seconds is twice as long as 1 second. So I can do things like count how many errors. This person made 0 errors, and this person made 10. This person made 20, which is twice as many errors. So I can start to do some kind of complicated things with those numbers in terms of comparing them to other things. So I can calculate a mean, I can calculate the range of those numbers, so errors rated from people had between 5 errors and 10 errors. The height of my participants was between 140 and 190 centimetres. And I can look at how much variance is within that, so we'll cover that within the kind of more hypothesis testing type section. But I can start to say, well, are they all clustered around the mean, or are they all very varied answers that I've got here? And the standard deviation is how much I vary from the mean. So I can start to say, well, actually, this is a really strong cluster. Something clear is happening here, as opposed to they're all pretty much random. So the important point to note here is that I have to kind of normalize them per something. So if I'm talking about errors, it has to be errors per minute, errors per task, errors per person. Errors is no good, because then how do I compare it to someone else? Okay, so that is NOIR. Nominal is the most crude, ordinal, interval, ratio. Okay, the last thing here is about correlations. So just being careful when drawing conclusions. So you might see something like this. So we have here the amount of cheese consumed on the left and the amount of people who die by being tangled in their bed sheets. And they kind of look the same. So can we say that eating cheese leads to you being tangled in your bed sheets? Like, probably not. It's just a similar progression. So there's some third factor that's influencing these things. And this is probably kind of more apparent here. So this is a correlation between, on the Y-axis, the number of Nobel laureate prizes per 10 million population, and the chocolate consumption per kilogram per year per capita. So how much chocolate do people eat? So Switzerland looks like it is super smart. It has lots of Nobel laureates per 10 million of their population, and they also eat lots of chocolate. So, does eating chocolate cause you to win Nobel Prizes? Or does winning Nobel Prizes result in you eating more chocolate? The third factor is probably just the culture within Switzerland, is that you go to school and you eat chocolate, and that's how they make money as a country, right? So, kind of, some of them are very interesting. You can just Google like strange correlations and find lots of them, but always being aware that just because two things look the same doesn't mean that are connected. And then I just want to look slightly ahead to the following week, just so that you've got some context for what it is we're talking about. I've mentioned a few times about having an experimental methodology or a research methodology, and this is pretty much what that looks like. So let's say there are 4 sections. I need to know who my participants are. I need to be confident that they represent the group of participants that I want this research to impact on. How many of them are there? Do they have any special characteristics? Is there do they use any technology to interact? Is there something that I need to record that would mean that this result might be different from another one? What are the materials I'm going to use? If I have 3 systems that recolor the screen for different types of color vision impairment, can I describe them? I might have 3 new email systems. Like when Google changes their email system, right? They have a subset of their users that they test it with. And so they have 2 systems, the old system and the new system. But can I describe these systems enough that other people understand what they do and how they might replicate them? What is my method or my procedure? What did people do? What tasks did they complete? In what order? How many times? All of the information, and this is the crucial reproducibility bit, right? Can I give enough information in there that I can give you the paper and say, go and repeat that study? So is it a step by step by step of what happened? And then how did I analyse the data? It's no good saying people did 10 tasks and I recorded them in this way, and then I analysed the results and the result is X. I need to know what that statistical analysis is, because that gives me confidence that the result is correct or incorrect. Again, hypothesis testing section. Okay, so that is at the end of these slides. What I would like you to do, hopefully you can watch these, you've got to the end. Have a read through them, have a read through the book. On My Dundee, there's that question section. Please fill in questions or even just topics for conversation in there, and we'll use that as the start of our discussion on Tuesday. All right, see you then. Thank you.